Greetings, welcome to Lab 5, Part 1, Hypothesis Testing. We continue our work in Chapter 4, transitioning from confidence intervals to hypothesis testing. So one of the first things we're going to want to be able to do is identify the null and alternate hypotheses and then be able to write those both in English, in an English sentence, and write them symbolically. So I've already gone ahead and opened up an R script file and populated it with all the questions necessary for this particular lab. So we're going to go ahead and get right after it, but if you need a few minutes, you might want to pause this and go ahead and open a new markdown file and label it assignment 6, lab 5, and we're going to start off in lab 5 with exercise 416. So you might want to have your textbook out also and get exercise 416 front and center for you. Of course, I did copy the whole thing here for you, so that'll be somewhat easier. Okay, so they ask us in this exercise to write the null and alternate hypotheses in words and use symbols for each of the following situations. So part A, in 2008, or since in 2008, chain restaurants in California have been required to display calorie counts of each menu item. Prior to menus displaying calorie counts, the average calorie intake of dinners at restaurants were 1,100 calories. After calorie counts started to be displayed on menus, a nutritionist collected data on the number of calories consumed at this restaurant from a random sample of diners. Do these data provide convincing evidence of a difference in the average calorie intake of a diner at this restaurant? Okay, so how would we state the null and the alternate hypotheses? So let's start off with the English version of them, and then we'll do them symbolically. Now, before I do this, I want to introduce you to a little bit of a coding trick here that in an RMD that allows us to do things like superscripts and subscripts and other cool things. It's a programming language that's separate from our Markdown called LaTeX, and it allows us to do all sorts of very cool stuff. So to type mathematics into your Markdown file, you open it with the $sign. And so I want to put in H, and then for a subscript, I use the underscore, so H sub O, and then I'm going to put in the colon here, and then I'm going to go ahead and close off the $sign. And we notice that it changed the color on that. And so that part right there is going to get interpreted by the RMD as H sub O, okay? All right, now we need to write this up in English. So what would we say? We say there is no change in the average calorie intake. The main thing to remember about the null hypothesis is it basically says it's the skeptical point of view. Nothing has changed. That this reporting of the calories on at the restaurant made no difference whatsoever in terms of what the diners were going to do in terms of what they ate. Okay. All right. Now I'm going to hit the double space and hit a return, and I'm going to open up with another $sign, and I'm going to put H underscore capital A colon, and then close it with a $sign, and that will, you'll see, I'll knit this in a minute, you'll see what happens here. Okay, so there is a difference in calorie intake for diners. I should put, there, let's put it in calorie intake. Let's put 4 diners in both of them because, gosh, we don't want to leave that off. All right, so that's what it would look like in English. So let's go ahead and knit this real quick so we can see what happens with that $sign stuff. I'm going to go ahead and move it over here so you can actually see it. And as you can see, is that the stuff that I typed in, notice it gave us the nice subscripts, the italicized H sub O and H sub A. Okay, so that's kind of cool. It's a nice way, and we're going to be using a lot of Greek letters from this point forward in our ventures in statistics. We're going to be using alpha and beta and mu and sigma, and it's going to be easier, more pretty, not necessarily easier, but it's going to look more pretty if you're able to actually type those in and have them come out in your RMD your markdown file as mu and sigma. Okay, so let's move on. So that was how we did it in English. Let's go ahead and put them symbolically. Okay, so to do it symbolically, I'm going to type this again, and so I'm going to again do the $ H underscore capital O colon, and now what would the null say? The null would say that mu was equal to 1100 calories, which is what it was before, right? So that's going to be, you put a forward slash, it's above your return key, and then type in mu equals 1100. Oops. So that's, excuse me, that's what the null hypothesis says. Double space and a return, and then put in $ H underscore capital A colon, and then again the forward slash mu. And now we want to put a not equals in here, right? Does that mean no differences? Remember, is a not equals in hypothesis testing. So you put a forward slash NE for not equals, and then put in 1100, put in a closed $, and let me go ahead and knit that right away again for you to show you what it looks like. And so take a look, you see we got our nice, beautiful, not indented correctly, I'll fix that in just a second, but you can see how we got mu's and we got an equals and a not equals in there. So I didn't want to put a space in there, that was my bad, or an extra space like that. Let's try that again here, just make sure there we go. Now everybody lines up perfectly because I wanted them. Okay, let's go take a look at part B. In part B it says, based on performance of those who took the GRE exam between July 1st, 2004 and June 30th, 2007, the average verbal reasoning score was calculated to be 462. In 2011, the average verbal score was slightly higher. Do these data provide convincing evidence that the average GRE verbal reasoning score has changed since 2004? Okay, so let's go ahead and put them in English first. So in English, we would say the null is what? There is no change in the verbal, we're going to abbreviate it as verbal reasoning score, VRS, for verbal reasoning score, okay? Yeah, the verbal reasoning score. Okay, so there is no change in verbal reasoning score, or, excuse me, my bad. Average, don't forget to put that word in there. That makes sense because we've got to talk about what is it actually we're measuring. There's no change in the average verbal reasoning score. Okay, and now come in and put in H sub A. And what we say? There is an increase. And this time they said that it looked like it went up. Right? Okay, all right, so that's what it would look like in English. Let's see what it would look like symbolically. So symbolically, we would have what? Well, let's see, how would you do that? Well, again, you're going to couch it in terms of the parameter mu. And so it'd be backslash mu. In other words, mu represents the population value. And so the no change would say that the mean is still 462. It has not changed from the previous rendition of the test, okay? And then what would the alternate say? Well, the alternate say, well, no, these people did better, and so the average verbal reasoning score actually increased. And so in this case, mu was greater than 462. Okay, so let's go ahead and knit that again so we can take a look and see what that looks like. Yep, looking good. Okay, alrighty then. So let's go ahead and kill that RMD for a moment there, our markup. All right, so quick aside, we're going to go over to the whiteboard for just a second. I want to talk about the three possibilities for null and alternate hypotheses and how those relate to our work in hypothesis testing. So three possibilities, okay? So there are three cases that we're going to look at. Let me shrink up my pen here just a bit. Okay, so case 1 is where the null hypothesis says that mu is equal to, let's go ahead and just stay with the verbal reasoning score, just for an example. I mean, this number can be any number. I'll show you a notation in a second, but just to make this a little less confusing, we're going to stay with just a number, okay? And then the alternate hypotheses, we said that mu was what? That was greater than 462. That's what we just did in the last example. Well, let's say that our researcher suspects that the verbal reasoning score went down. In other words, was less. So in this case, the change here, remember that the alternate always indicates our change. The change that they suspected that happened, remember HA, that's our researcher's hypotheses. That's the hypothesis that says the change has happened. The change here that they're suspecting is that the mean got larger from status quo. So the mean is bigger, is case 1, all right? So make sure we get that before we move over to case 2 here. So what if our intrepid researcher said that, no, I think that the mean got smaller in this particular administration of the GRE? Well, in that case, then what our researcher would be suspecting, is the alternate hypothesis, is that mu is less than 462. In other words, in this case, the suspicion is that the mean, or the researcher's hunch here, is that the mean is less, or the mean is smaller than it was originally, okay? It's smaller, it's less than, it's decreased, it's any one of those. All right, now the third possible case is, I don't know. It's just not what you say it is that the mean was equal to 462 versus, I don't think it's the same. And in that case, what you would say is that the mean is not equal to 462. And in this case, what that says is that there is a difference. It's either bigger or it's smaller, but I'm not sure which. So in other words, that the mean differs. So it's bigger, it's smaller, but I'm not sure which of the three. Okay, so these two tests up here, case 1 and case 2, these are what we refer to as a one-tailed or one-sided test. So these are both one-sided test or one-tailed test, as many times as referred to as one-tailed, because you'll see in just a sec, or as we move through this, is when we draw our representative distribution of the null hypotheses, where we put the p-value, or where we're going to shade the p-value, is going to be in one tail or the other. Down here, this is a two-tailed test. So case 3, we would refer to that as being two-tailed. This is very important stuff. Make sure you get this in your comp book, all right? Now, one other thing that really is kind of handy, and we'll repeat this as needed, is that the direction of the tail is going to be given to us by the inequality symbol. So in case 1 here, this is one-sided or one-tailed to the right. Why do I know it's a right-tailed test without even doing anything more in it? Well, look at which way this is pointing. The inequality symbol makes an arrowhead and it points to the right. This is one-sided to the left. In other words, my direction of extreme, where I would go to graph and plot my p-value on my normal distribution, is going to be to the left. In the two-tailed one, then that means there's going to be some area to the one side and some area to the other side on the distribution. Okay, so that's a quick overview of that. We'll come back to that several times as we work through stuff, but start getting that in your comp book. That's important material. All right, let's go back to the regularly scheduled program here. Let's go take a look at exercise 418. So in exercise 418, says in exercise 414, we presented the results of the survey showing the average age of women of first marriage is 23.44 years. So we did this in a previous problem, and we actually worked this. Suppose a researcher believes that this value is increased in 2012, but he would also be interested if he found a decreased. Below is how he set up his hypotheses, a symbolic version of them, please indicate any errors that you see. Okay, so I typed them up using a little bit of LaTeX. To get an X bar, by the way, you put in bar with a forward slash X, and so whatever the next character after you say bar to it will have the bar over the top of it. If you want a long string of things over it, then you got to do something a little different. We'll talk about that separately. And you notice that I ended the dollar sign again as in the previous ones and then started doing some English. Okay, so let's knit this real quick and let's take a look at that. All right, so we want to focus just on this part right here. So these are the lines they ask us to evaluate what is wrong with them. What did they do wrong? Okay, so a couple of things are wrong here. So first one is this. We never test on the sample mean. We're testing on the population. In other words, the inference here that we're making is we're inferring for the population. We're not inferring about our sample. We know everything we need to know about our sample. The inference is that we're basing the result of our sample back to the entire population. So that should not be an X bar, that should be a mu. Mu represents the population mean, X bar represents the sample mean. So that's the first mistake that was in there. And the second one is he would also be interested in if he found a decrease. So in other words, he really wanted to run a two-sided test because he thinks it might have increased, but he's also interested in a decrease. Increase and decrease both means he's got a two-tailed test, as he just thinks there's some difference in the age. So the two problems here is that he should have been using mu. So let's come over here and type these in. So the value of the mean, oh, such a terrible typer. Okay, just is they, okay, or the, okay. The mean should be, and then I'm going to go ahead and put in a backslash or forward slash mu here. And the alternate should be a not equals. Okay, so let's go ahead and knit that again real quick and see how my response looks here. Okay, where was it? Oh, there we go. So there we go. The value of the mean should be mu and the alternate should be a not equals. Okay, cool beans. All right. So let's go ahead and do one more in this particular video and then we'll move on, okay? All right, so Thanksgiving spending part 2. So exercise 412 provided a 95% confidence interval for the average spending for American adults during the 6-day period after Thanksgiving 2009. And so with 95% confidence, if I recall correctly, we had that the mean spending was between $80.31 and $89.11 in 2009, okay? So a local news anchor claims that the average spending during this period of time in 2009 was $100. What do you think of his claim? I think he failed stats. Why? Well, because look, how could it have been $100 if our estimate of what the value of the spending was is this interval estimate right here? His $100 is much larger than what our interval estimate is. Is much larger than what is given by our interval estimate. Okay, all right, so let's go down and take a look at part B here. Would the news anchor's claim be considered reasonable based on a 90% confidence interval? Why or why not? Okay, so yes, remember our previous one is a 95% confidence, and if we changed it to 90% confidence, would that help our intrepid stats failing news anchor's cause? And the answer is no. Why? Well, what happens when you lower the confidence, right? Well, think about it this way. Go back to the fishing analogy. You just made a smaller net, didn't you? Remember we talked about the point estimate as being a spear and a confidence interval like being a net. And so if you're trying to fish, it's a lot easier to catch fish with a net than it is with a single spear. So a 90% confidence interval means you're only 90% confident that you capture fish, which means you're using a smaller or more narrow net. So no, the interval would be narrower. Without even having to calculate it, we know it's going to be narrower. So the value of 100 still would not be in our interval. Okay, cool beans. Well, let's go ahead and we'll stop this one for now. There'll be a bunch more coming up just right after this one. Hopefully this stuff helps. Be sure and have your comp book out while you're doing these and typing things up, and I'll see you back here in just a bit.